So on the left side you've got unit 1, and on the right side you've got unit 2. So let's have a look at the IRF stack. So by doing a display IRF, here you've got unit 1 being the master and unit 2 being the standby. So we can do that the same on unit 2, display IRF, and you will get the same type of information, the plus sign meaning that we are on the console port of unit 2. Now let's have a look at the version that is currently running. So display version. Okay, we are running R2311P03. Okay, and let's have a look at the files that are already uploaded on the flash. Okay, so on unit 1, you've got the existing version 23, and we've got the new version that has been already uploaded in order to save time for this video. So we are going to upload to R24.16. Let's have a look at the configuration of the equipment now, just to have a check of how the link aggregation are distributed for uplinks and for the downlinks to the server. So display current configuration, and you'll see that we've got a bridge aggregation 1 that is permitting VLAN 1155, that is the uplink. Bridge aggregation 2, that is to connect a Citrix VM, and then we've got bridge aggregation 3, that is to connect an ESX server. So the interfaces, physical interfaces, are bound to the bridge aggregation with LACP, knowing that the bridge aggregation are in a link aggregation mode dynamic, meaning that we are doing LACP. So now if I go to the CLI to do a display interface brief, we should see on the bridge aggregation 1, 2 and 3, those bridge aggregation being up, and the bandwidth, so 2 times 40 gig for the physical link, meaning 80 gig of throughput for the uplink, and 2 times 1 gig for the downlink to the server. So that's it for the configuration, pretty basic, just layer 2 to have a dual attachment from the top of rack access layer to the core switch for the uplinks, and the same for the downlinks to the server running LACP as well on the driver of the NIC card. One important point to consider is the usage of multiple active detection for this incompatible upgrade. Indeed, during this upgrade, we will have 2 versions of code that are incompatible to run together in parallel on the 2 members of the stack. So we are going to use a stack split process in order to have these 2 parallel systems running with different versions. So for that, we need to activate multiple active detection to activate that split. So this is done in the configuration by there is different multiple active detection capabilities, either LACP-MAD or BFD-MAD or ARP-MAD. We are using in that simple case the LACP-MAD, which is configured on the bridge aggregation 1 with MAD enable. And if I do display MAD verbose, you'll see that MAD enable on aggregated port bridge aggregation 1. Let's see now that we are going to process with an incompatible or a compatible upgrade. In order to do that, you do a display version compatibility matrix file, then boot, flash, and the new version of the firmware, so that would be 24 in that case, then the system part, flash 24, and that command output is providing you the information that it's an incompatible upgrade. Before upgrading, let's have a look at the traffic monitoring between the servers in order to see activity on the circuits and see what happened in terms of impact when we are losing Unit 1 or Unit 2. So in terms of monitoring, we've got the two uplinks that are on the top of the screen. The left part is for member 1 and the right part is for member 2. So we've got the 40 gig interface for the uplink Unit 1 here on the left and 40 gig interface for the uplink Unit 2 on the right. The downstream server are here and here. So let's start the Icmp Flows. So the first server consists in those two windows here, and the second server, the test2 server, those two windows at the bottom. So on the first server, we are going to issue ping -e 1 milliseconds, timeout being set to 10 milliseconds, -q because I just want to have the end result statistic. And this is the destination server that is below the access top of rack stack. So let's start this. You should see in terms of monitoring flows that are reported as number of packets per second, green being inbound of the interface, blue being outbound of the interface. So here this is received on the uplink and sent to the core from the uplink, and on the bottom this is the same for the interface to the server. So let's start on the same server to ping another destination IP address. So this was 10.10.155.140 here, 10.10.155.135 here. So same source IP address and destination being different, and you see here actually this load here. Let's do the same on the second test server. So different source IP. You see that this uplink is being loaded here and this link uploaded here, and finally the fourth Icmp flow. You should see on those 4 flows all uplinks are being used and all downlinks are being used. So let's proceed of the upgrade of member 1. So let's get back to member 1 console, and let me put member 2 console as well so that we make sure that everything is running properly. So I'm going to issue the bootloader command in order to upgrade with the incompatible process the member 1. So bootloader file boot flash with the boot file, so it's R24 system flash 24 slot 1. So it's going to verify the file and set up the file as the main image for Unit 1. Okay, now this is done. I can do a display bootloader to verify that the next, so the current is R23, but the next one would be R24. Let's now reboot slot 1. You see on the console port a lot of information. So you see that board is rebooted on slot 1 as an information message being sent to slot 2. Now if I do display IRF on member 2, you'll see that only one switch is a member of the stack, which is the master and Unit 2. You see Unit 1 being rebooted. At this stage, if we want to check the impact of that of unit 1 leaving the stack, we can stop the ping or start the ping again, or leave the ping running until unit 1 is restored. So let me just leave the ping running while unit 1 is fully restored. So in order to save time, I skip a little bit the booting process. So right now, the member 1 is decompressing the system image after the boot time, the boot home time. Let's see what will happen as soon as it did boot unit 2, seeing the unit 1 being up. So as unit 1 system is starting, you see unit 2 receiving or detecting that the IRF port is up, but not able to receive any IRF packet. I remember that there is some IRF message keep alive between the two units, and it cannot receive that IRF packet. So so the IRF port is considered to be down. So that's why you receive those messages in the log. So we'll see in a few seconds while unit 1 is completely restored, what will happen in terms of split and multiple active detection. So let's wait a little bit. Here we go. So we've got unit 1 fully restored, and then you see MAD detect multiple active devices detected. Please fix it. And then you see that the interface 40 gig uplinks to the core is now being set as down on unit 2. So you see that unit 2 is physically shutting down all the ports, as this is to be the slave in the stack during the IRF stack split, because member 1 has the lowest member ID, so member 1 must be the master in the stack in this case. Let's have a look at member 1 CLI, display IRF. So we've got only one, display interface brief, and you see that the link aggregation are set to half of the bandwidth previously set, as I've got half of the link of unit 2 being down. So this is I would say that state is an intermediate step, while unit 1 is upgraded to the new version and unit 2 is still to the old version, and then we are in a split situation. Let's have a look at the result of on the traffic being impacted by this. So as you see on the top, this was my initial pings that stop here on the uplinks to unit 1 because of unit 1 rebooting. So you see that the reboot lasts something like 6 minutes, and then the unit is back. And here you can see on the graph that unit 2 take over the load of unit 1 on those uplinks, and then unit 2 stop forwarding due to the split. So all messages are already error because of well, unit 1 disappeared and unit 2 disappeared as well. So I can reset the graph for unit 1. That will obviously show all the traffic running. So let's stop the pings. And let's have a look at the overall impact of the two points. That is, the first one is unit 1 leaving the stack while it reboots, and unit 1 being restored as the master, and which is the main impact actually. Okay, because unit 1 leaving the stack, this is just a matter of shutting down links in a dual leg architecture, whereas unit 1 taking over the whole of the master is a complete, I would say, restore of the automatic restore of the split process. So on this first Icmp flow, we have received 736,063 packets. So and transmit packets was 736,155 packets, which means a difference of 92 packets being dropped. So that's 920 milliseconds for that first flow in terms of interrupt. Then on that one we have about the same, so 97 packets being dropped. On that one we've got 65 packets being dropped, and yes, that's it. And on that one, the last one, that is about the same, 65 packets being dropped. So a maximum of 972 packets being dropped. So means that overall we had less than 1 second outage on overall process between the first initial state where we start to load the firmware back to the fact that unit 1 is completely restored. So at this stage, let me simply reboot unit 2 with the new firmware. So let's go to unit 2. And do a boot loader. File, boot, flash, or system, slot 2, main. Okay, so now let's restart the ping. Okay, those ones should still be in error because of the split. And now reboot slot 2. I'm not going to save the configuration, and I will reboot. Here we go. So member 2 is rebooting. We've got a faulty state regarding unit 2 that was in a mad situation, and we'll see how this is being restored. So unit 2 did restart, so system is starting. You may see on unit 1 that you see that the IRF port is up, and there are some information being exchanged on the IRF circuits between the two members. So slot 2 and interface 40 gig 2 /049 and 41 are being actually seen on unit 1, which proves that the IRF is up. If I do display IRF, you see that unit 2 is there. It's still not completely ready to forward traffic. If I do a display interface brief, yeah, uplinks are still not up on unit 1, but they are becoming up here. Okay, so now unit 2 is ready. If I do a display version, you see that on slot 1 and on slot 2, I've got now R24 running, display device verbose. Here we go. You see the software version that is running on that box. On those two, slot 1 and slot 2, we've got now the full upgrade. So display interface brief now. You see 80 gig for the uplinks and 2 times 1 gig for downlinks to the server. Now it's time to look at what was that the traffic impact for that transition, unit 2 rebooting and upgrading to the same image than unit 1. So that first flow here, we have no packet impact. Here we had 11 packet, so 110 milliseconds. Here we had no impact, and here we had no impact. Pretty much as expected, because we are just putting new circuits in the existing link aggregation, which means no impact. So overall, you can see that if we cumulate the total impact of upgrading unit 1 first and unit 2, we have, as I said before, 92 packet lost here on this first drop, and then we had on that following one 11 packet, which is a total of 103 packets, so a bit more than 1 second. So depending on scenarios that you use, you'll see that a 2 seconds, less than 2 seconds impact is something that you could achieve, and making sure that operational team can in all cases perform an upgrade of two 5900 as a top of rack, doing layer 2 and maybe layer 3 static or connected for operational in the data center. So that being said, maybe one slide to conclude. As a nutshell, please use the bootloader command for this process on the top of rack. Use multiple active detection, preferably BFD MAD. It's a bit more, I would say, aggressive and a bit more responsive in terms of MAD detection. You may turn down temporarily any BFD probing that you might use for whatever reason, VRP or whatsoever, and you need to use temporary static routes instead of a dynamic routing protocol if you use layer 3 on your top of rack. Thank you for your attention.